Am I audible, ma'am? Am I audible, ma'am?
Yes,
Thank you.
am I audible, Vigneshwari? Am I audible?
Yes, ma'am, you are audible, ma'am.
Thank you.
Happy idea.
Good afternoon, Shyamla ma'am.
Good afternoon, ma'am.
Hearty welcome to you, ma'am.
Thank you, ma'am. Thank you so much.
also thought like let me do what how much ever possible.
Sure.
यही का ये बच्चा सूख जाए घर जाके
Center. Group. Next.
Am I audible?
Yes, ma'am, you're audible.
Thank you, ma'am. Thank you. Ma'am, shall we start the session?
Yes, ma'am.
Good afternoon to one and all present here. The beautiful thing about learning is nobody can take it away from you. With this note, on behalf of Faculty of Education, Dr. MGR Educational and Research Institute, we extend our gracious welcome to one and all present here for the workshop on SPSS. With a tremendous pleasure, we would like to welcome our renowned speaker, Dr. A. Shyamla Devi, Assistant Professor, Department of Education, University of Madras, Chennai. Hearty welcome to you, ma'am. It's a privilege for us to extend our gratitude to our Honorable President, Engineer ACS Arun Kumar, and all the executives for granting us permission and the support to conduct this workshop on SPSS. Next, it's our duty to extend a congenial welcome to all the executives, heads, professors, faculty members, research scholars from various institutions. Finally, I would like to extend my best wishes to each and every one of you for a fruitful and rewarding experience throughout this workshop. May it serve as a catalyst for your personal and professional growth. Together, let us strive for the excellence in education and work towards creating a brighter future for our students and the society as a whole. Once again, a congenial welcome to one and all present here. Now, I call upon Mrs. Vigneshwari, Assistant Professor, to introduce the resource person.
Thank you, ma'am. A warm welcome to one and all present here. It's my great privilege to introduce the resource person, Dr. A. Shamla Devi, Assistant Professor, Department of Education, University of Madras, Chennai. She has about 15 years of experience in the Department of Education. Her specializations are research methodology, statistics, SPSS, women education, and philosophy. A renowned person with a good reputation in her research profile. She has presented many papers in national and international conferences. Also, she published 7 international articles in reputed journals. She has been guided 50 M.Ed students, 12 MPhil, and 2 PhD scholars. She was nominated as the special officer for Dr. A.L.M. School, Palavakkam. She served as a resource person for various seminars and workshops. She has been in various positions like a question paper setter, convener, and examiner, and lot more. She is truly a remarkable workaholic and ideal professor with us today. It's a pleasure of mine to invite you to host a session on SPSS. We are eagerly waiting to hear from you, ma'am. Ma'am, kindly accept our virtual bouquet as a token of love. Please, ma'am.
Thank you, ma'am. Thank you, Vigneshwari, ma'am.
Thank you, ma'am. Now the session is yours. Please, ma'am.
Yes.
தெரியலையா சரி விடுங்க இப்ப ஆன் பண்றேன்
Okay. So good afternoon, everyone connected to this online mode workshop on SPSS. So before presentation, I would like to explain few things. That is, we can complete the SPSS workshop in 2 days, but the organizers plan to conduct in 3 days because they want to touch the fundamental part, the basic of research and statistics, and thereby proceed into the SPSS package and analysis part. So today, I planned my presentation in such a way that first day I will be focusing on the basic part, that is basic research and statistics part. The theoretical part I will be handling in day 1, and day 2 I will be discussing on SPSS. So about the package and what are the windows available in SPSS, and what are the various components and the properties of the components, and how to enter the data in SPSS, as well as how to import the data from Excel to SPSS, how to export that output from SPSS to Word. So those things I will be discussing in the second day. Along with, I will be discussing how to do descriptive statistics. So descriptive statistics analysis will be handling in the second day. And third day, I will be focusing on inferential statistics like t-test, f-test, correlation. If time permits, I will also touch regression analysis on the third day. So this is how I plan to proceed my presentation, because the coordinators are very particular that we have to start from the fundamental, the foundation, because the target audience here is PhD scholars. So unless and otherwise they are good in this basic part, it is very difficult to focus on the analysis part. So hence I plan to focus on the basic and fundamentals on in day 1. Okay, so with that explanation, the next one is I will finish the presentation in 1 hour, and 15 minutes we can have for discussion. We can have discussion to clarify your doubts and other things, and we will wind up the session by 3:15 because I have some other work. Okay, and with that, let me move into my presentation. So I'll share my screen now. I hope my screen is visible. Yes?
Yes, ma'am, it's visible, ma'am.
Okay,
Yes,
okay.
ma'am.
Thank you, ma'am. Thank you so much. Okay. So, okay. Before moving into my presentation, I would like to start with an anecdote. That is, there is a village. In that village, one old man, he was taking care of his farm. It is a cattle farm, and he is taking care of his cattle farm. One fine day, one young man, well-dressed, well-educated, highly educated, and decent man who came to his farm, and he asked the old man, may I know the square, so shall I tell the square feet of your farm? It is 2,500 square feet. This old man was puzzled out. Who is he? All of a sudden, he is coming to my farm and telling the square feet of my farmhouse, that is cattle farm. And he's also telling the statistics of how many cattle he has and what are the various breed he has and the number of breeds, everything, all the statistics, pakka, he is giving to the old man. Immediately, the old man asked him, who are you? I didn't invite you to my farm. I didn't ask you about the statistics. All of a sudden, you came and you're giving all those information. Who are you? He asked. You know what reply he gave? The young man told that I'm a researcher. Okay. So it sarcastically tells that a researcher. So the young man, the old man said that, see, I know very well about the square feet of my farmhouse. I know how many breeds I have. I know the types, everything I know. Then why are you telling all those things to me? Because the young man said, I am a researcher. So the young man told that nearly I spent 1 month to found this data, the square feet, the breeds, the types, everything. Nearly I spent 1 month to find these statistics. So the old man told, why can't you approach me in day one? In day one itself, I would have tell you about all those statistics because I know this already. So this sarcastically tells the scenario of the condition of our young budding researchers, because our budding researchers are doing research for the sake of doing research. They are not interested whether to whom we are doing, whether our research is going to contribute to the society, whether we are going to contribute to the nation, are we going useful research for the society, whether my findings is going to useful for the policy making. We are not interested about that. So first and foremost, the budding researchers, we have to do research for this, not for the sake of doing research. We have to do research in order to contribute to the society. We have to do research on the unresearched area and unfocused area so that we can contribute more for the country. And this kind of research will be very helpful for the national development. Okay. With that, so this is the overview of my today's presentation. So first I'm going to touch what is research, the steps of research, variables and its types, the scales of measurement, basic of statistics, statistics and its classification, types and forms of hypothesis, at last level of significance. Okay, so this is how I'm going to proceed the presentation. So first one is research. So we all know what is meant by research. That is, research means, we all know research means searching again and again. So searching again and again is research. See, as researchers, we know that we should not duplicate the topic, right? So we should take some innovative topic, new topic, so that we can contribute more to the country. But searching again and again means what? Suppose if the topic really demands for researching, then we can duplicate the topic. For example, nowadays we need to do more research on inclusive education about NEP 2020. In that case, we can duplicate the research problem. Nothing wrong in that. But duplicating the problem which has been already done so many years back, those problems have to be avoided. But we can research again and again. Why we have to research the same problem? If I'm going to take the same research problem, what previously has done, I will not arrive at the same conclusion, same finding. I will arrive at different findings if I conduct the same research in the consecutive years. So we can do research again and again so that we can arrive at different solutions to the problem. So the purpose of research is two. We are doing research for two purposes. Okay. Can anyone type the purpose of research, purpose of conducting a research in the chat box? Yes. What is the purpose of conducting a research. To gain insight, Kiran. Okay, thank you, Kiran. To gain new insight. Any other answer? Search knowledge to find solution to the problem, to explore more about the topic. Okay. To find solution for unknown field. Okay. Go beyond what is available. Okay. Okay. Thank you. Thank you so much all. See, the purpose of conducting research is to, number one is to find solution to the problem that we all know already. Okay. And the second one is, yes, to fill the knowledge gap. Okay, so to find solution to the problem, and the second one is to fill knowledge gap. See, we know two approaches of research. One is quantitative research and another one is qualitative research. So that nowadays people are doing mixed research, that is mixing both quantitative and qualitative together. So quantitative research and qualitative research. Now tell me, finding solution to the problem and to fill the knowledge gap. Which one is quantitative and which one is qualitative? So one is quantitative approach and the other one is qualitative approach. Can anyone give me the answer? Finding solution to the problem and to fill the knowledge gap. Any guess? Qualitative. Which is qualitative? Okay, I'll tell you. See, in quantitative research, you know, for example, if I quantitative research, what we will be doing means we will, okay, we'll go for review studies. Okay, I will review more studies. After reviewing, I will find the gap, research gap, or I will find a lacunae. So in order to fill the lacunae, I will conduct a research. So that is quantitative research. That is not qualitative. Okay. So quantitative researches will start with review. So initially what the guide will ask you to do, the guide will ask the scholars to go for review studies. You just go and review the abstracts and studies from Soap Ganga and other online sources, and then print media, other media. The guide will ask us to go for reviewing the studies. While doing the review studies, so first and foremost, we should have the broader area. Once you fix the broader area, you can also go for review. Otherwise, before that itself, we can go for review studies. So when you review the studies, at one point of time, you will find a research gap. Okay, so that is called knowledge gap. So in order to fill the knowledge gap, you will do the research. So an attempt is made to fill the research gap. The investigator has made an attempt to do research in this particular area. This is how you will be writing in your second chapter under gap identified, research gap identified. I used to ask my students to write this in specific while doing quantitative research. They have to write research gap, because after reviewing the studies, they will be identifying the lacunae area. So in that lacunae area, they have to conduct the research. That is quantitative. Then what is qualitative? Qualitative data is all about finding solution to the problem. For example, you know, transgender. So transgender, they are facing a lot of problems. So what I will do? So in order to, so the problem is like that, the problems faced by transgender in the society. So problems faced by transgender in the society. So this is my problem. So what I will do, I will go and interview the transgender, or I will conduct a focus group discussion. I will discuss with transgenders, and I will collect the information about the problems faced by them. Right? And then I will try to find solution to this problem. So that is qualitative research. So qualitative research is all about finding solution to the problem, and quantitative research is all about filling the knowledge gap. For example, if I want to do research among transgender, about transgender, I will go for review studies. In that review studies, I will found that among these variables, none of the studies are conducted. So I will be choosing the social anxiety or mental health, or the combination of these two variables are not much done by the researchers. So in order to fill the gap, the researcher like to conduct the research on the social anxiety and mental health of transgender. So filling the knowledge gap, that is quantitative research. So research, two approaches we have. One is quantitative research and qualitative research. In order to find solution to the problem, we conduct qualitative research. To fill the knowledge gap, we will be doing quantitative research. Okay. And the next one is meaning, research. So that is research refers, it is a process wherein activities are carried out systematically to find solution to the problem. Just like that, we can't conduct a research, which means we should conduct the research in particular steps. Step 1, step 2, step 3, step 4. That is systematic. Okay, so systematic way of finding solution to the problem or to fill the knowledge gap is called research. So research refers to a process wherein activities are carried out systematically or scientifically to find solution to the problem or to fill the knowledge gap. So then at most we are going to find solution or to fill the knowledge gap. We are conducting the research. It can be both quantitative, qualitative, or a mix of both quantitative and qualitative together, right? Okay. And second one is steps in research. So the first step, we all know, identification of the problem. Okay, identification of the problem. So now I'm going to focus only on quantitative research because we are going to deal with data analysis part. So hereafter, I will be discussing only on quantitative research. So the first step is identification of the problem. So what is meant by identification of problem in quantitative research? Here we are not going to identify the problem. Identification of the problem means identification of the variables. So what actually we are doing in quantitative research is we are going to identify the variables first. So that is called identification of problem. So how to identify the variables? By reviewing the previous studies, we can identify the variables. You know, what are the three essential components of a title? A title should contain these three things. What are they? Can anyone text in the chat box? The title should contain these three components. What are they? Yes. Variables. Okay. Any other answer? Sample. Very good. Independent, dependent variable. Okay. So two components you have to, yeah. So variable is correct as well as sample. So the title should contain variables. It can be one variable or two variable or three variable or more than three. It's up to you and your supervisor. So the title should contain variable, geographical region. Okay, fine. So variable and the sample to whom we are going to conduct the research. So the sample. And the third one, your geographical area. So where you are going to conduct the research, in Chennai or Thoothukudi or Tirunelveli or Kanyakumari, the geographical area from where you're going to conduct the research. And one more important thing, more than geographical area, one important thing is the methodology. That should the title should contain the methodology also. While reading the title itself, we came to know whether it is an experimental research or a survey research. So experimental means certain keywords, effectiveness. From this keyword, we can easily identify it is an experimental method, or otherwise it is a survey method. So these three components are very, very important in a title. That is the variable, the sample, the geographical area. In addition to this, the methodology is also very important. Whether it is survey method or experimental method, we can't write the methodology, but while reading the title, we can identify whether it comes under survey or it comes under experimental or so and so. Okay, so these are the essential components. So in the first step, that is in identification of the problem, first we have to identify the variables, or we can do in this way. We can identify the sample first and we can go for the variables which is suitable for the sample. For example, now I really want to do research on a transgender. Okay, so in that case, transgender means I will go for the variables which suits for transgender, like social anxiety, emotional intelligence, mental health. If it is school students, for example, my samples are school students, means learning style, brain dominance, academic achievement. So I will choose my variables according to my sample. So either you go for variables, after that you can choose your sample, or you choose your sample first and then you can go for selecting your variables. Okay, so first one is identification of the problem. Once you identify the problem, the second one is selection of the problem, because in some statistics books they have given identification of the problem, in some books they have given selection of the problem. Both are different or same? Identification and selection
Differ, ma'am.
Yes, both are different, right? So identification means it is a broader one. And then selection means it is something widening the title. See, for suppose, in order to conduct this workshop, the coordinators, they would have identified some 5 resource person. Okay. After selecting the 5 resource person based on the availability of time, date, they would have select me. Right? So once you identify the variables, after that you have to select the variables in specific. So that is the second thing, that is selection of the problem. So once you identify the variables, you have to discuss with your guide. After discussion with the supervisor, you can go for selecting the variables. So the first step is over. Okay. And the second one is review. So in the beginning, before identification of the problem itself, we should go for review. After identification also, we should go for review of related literature, because now I have selected the variables. So now I'm doing literature review only on these variables I have selected. Okay. So that is the second step. And then formulation of objectives and hypothesis. So now we have to formulate the objectives and hypothesis based on the review studies. Based on the review studies, I came to know, okay, for example, if it is transgender, I may have a doubt how many sample I have to collect, whether 1,000 sample, it is not possible to collect 1,000 sample for transgender, right? So while doing review studies, I came to know what are the sample size the previous studies have taken. So with that knowledge, I can fix my sample size. And what are the tools which are being already available, standard tool or any other tools available in that particular variable. So with that knowledge, we can go for formulating the objectives and hypothesis. Okay. And next one is tool construction. So once you formulate the objectives and hypothesis, we are supposed to construct the tool. So tool construction also 3 important things. So you have 3 choices. Number 1 is you can go for standard tool. So standard tool means already available tool, but one important thing is it must be recently developed tool. So recent 10 years tool means it is well and good. Otherwise, we can't use, even though it is a standard tool, it must be recently developed tool. Otherwise, don't go for that. Okay. Suppose if it is developed in the year 2001. So now we can't use the tool. So in that case, you can go for modification of the tool, or we can say adaptation of the tool. You can add certain items, you can delete certain items, you can modify the standard tool. So that is the second choice. And third one is you're not satisfied with the standard tool, you're not satisfied with modification also, then you can go for self-made tool. You can go for developing your own items based on your sample, the sample you have selected, you can interview the sample. And based on the data you collected from the interview, you can go for developing the items. So you have 3 choices. Number 1, you can go for standard tool. Number 2, you can go for modification of the standard tool. Number 3, you can go for self-made tool. And next one is data collection. So once the tool construction is over, straightly you won't go to data collection. After that, we will be going to pilot study. So 10% of your population, suppose I fixed my sample size as 1,000. I have to conduct the pilot study among 100 students. I have to try out my tool. Okay. So if it is standard tool, we have to establish the reliability of the tool, whether the consistency is there. You have to check the consistency of the tool. If it is standard tool, if it is modified or self-made tool, then you have to establish both the validity as well as the reliability of the tool. See, suppose in one student, one M.Ed student, after establishing the reliability, the value is 0.4, something like that. If the reliability value is 0.4, you're not supposed to use the tool, because the reliability value should be greater than 0.7. Unless and otherwise it is greater than 0.7, you're not supposed to use the tool. Go for some other tool, do the process again, and go for some other tool. So that is the only choice in your hand. So you check the reliability first. Even for standard tool, we have to check the reliability. If the reliability value is more than 0.7, we can use the tool. Otherwise, we should go for some other tool on the same variable. Okay. So after pilot study, we can conduct data collection. Okay. Once the data collection is over, we will be doing data analysis. So now in this session, we will be focusing on the data analysis part. After data analysis, we will be concentrating on the findings and writing the interpretations based on the findings, giving suggestions and other things. Okay. So now we will be focusing on the concepts which are essential for data analysis. Okay. So next one, what variable and its type. So what is meant by variable? So variable means anything which varies is variable. Anything which varies from one person to another person, that is called variable. So variable is a trait or an attribute or a characteristics which varies from one person to another person, that is called a variable. Okay, suppose I have taken 5th standard students. So among 5th standard students, if I take their height, the height will change from child to child. So height is a variable. Similarly, weight, the weight will change from child to child. So weight is a variable. Similarly, intelligence, the intelligence will also change from child to child. So intelligent is a variable. Now tell me, what is the opposite of variable? Can anyone give the answer in the chat box? Opposite of variable. Variable is it keeps on change from person to person. So opposite of variable is? Yes, very good. Constant. Okay, now in this example, what is your constant here? I gave you one example, no? In that example, the constant is 5th standard students, their age. Okay, yes, 5th standard students, because all the students will be around the same age only. So age is constant here. Okay, only the other aspects, that is their gender, then what? Their intelligence, height, weight, their interest, their attitude, their aptitude will change from child to child. So as a researcher, our research should be on the variable and not on the constant. So we must be very, very specific while choosing the variable, because we should not choose a constant as a variable, right? So we have to, which standard that student? 5th standard. Okay. Okay. So a variable is a trait or an attribute or a characteristics which varies from person to person. I have given an example for that too. Okay. And next. So types of variable. The first one is continuous variable versus discrete variable. So what is meant by continuous variable and what is discrete variable? See, continuous variable is which can be both in whole number as well as fraction. Discrete variables will be only in whole number, not in fraction. For example, number of students in the class, it is a discrete variable. It cannot be in fraction, 50, 40 or 30. So this is a discrete variable. Height of the students, height of the student is a continuous variable. It cannot be always in whole number. It can be 4.3 or 4 points. It can be in fractions, right? So height, weight or continuous variable, and that number of students in the class, number of boys, number of girls, these are all discrete variables. So those variables which can be written both in whole number and fraction or continuous variable, those variables which can be written only in whole number or discrete variable. Okay. So next one is, can you give some example for continuous variable in the chat box? Yes. Weight, height. I already, okay. IQ. Okay, now academic achievement. Tell me whether it is a continuous variable or discrete variable. Yes, you have simply given marks. I want to know whether it is a continuous variable or discrete variable. Academic achievement.
Continuous.
Yes, yes. So academic achievement is a continuous variable because 35 and off, 35.5 or 50.5, it can be both in fraction as well as whole number. So achievement is a continuous variable, right? And we all know what is discrete variable. Can you give one example for discrete variable? Number of students in the class, number of days in a week, okay, number of months in a year. So these are all, yes. Cumulative grade point is a continuous variable. Okay, thank you, Kishore. So now you know what is continuous variable and what is discrete variable. Number of classrooms, very good. So number of classroom is a discrete variable. Okay, so next type is independent variable versus dependent variable. So what is independent variable and what is dependent variable? So independent variable is one which is going to manipulate the dependent variable, and the dependent variable is highly dependent on the independent variable. Right? So I'll give you one example for this. For example, the learning styles and academic achievement of 9th standard students, right? So based on the learning style of the students, the academic achievement marks will differ, right? So academic achievement highly depends on the learning styles of the students. This learning style is going to manipulate the academic achievement, right? Now tell me which is dependent and which is independent. Learning styles, academic achievement. Can I have the answer in the chat box? Learning style is independent, academic achievement is dependent. Okay, thank you. Okay, one more example. Job satisfaction and mental health of school teachers. Okay, now the title is Job Satisfaction and Mental Health of School Teachers. Now tell me which is dependent and which is independent. Job satisfaction is dependent. Okay, I'll tell you. See, if the teachers are more satisfied towards their job, they will have very good mental health. If they are not satisfied towards their job, their mental health will be very poor. So the mental health is depend on job satisfaction, right? So job satisfaction is independent variable and mental health is dependent variable. So the independent variable is going to manipulate the dependent variable and the dependent variable is highly dependent on the independent variable. So first, we discussed about continuous and discrete variable, and second, dependent and independent variable. We have intervening variables, extraneous independent intervening variable. Many variables are there, but I'm not going to touch that. Mental health is not independent variable. Mental health is dependent variable because the mental health of the teachers depends upon the job satisfaction. See, I am in government sector, so I'm very much satisfied towards my job. So my mental health will be very good. But if you take the teachers working in private sector, they will be working more hours. So they will be stressed out because they don't have good job satisfaction. So their mental health will be affected due to that. So mental health is dependent, job satisfaction is independent. Okay, with that, I'll move on to the next one. I'll come to this variable again at the end of the session. And next important topic is scales of measurement. This is very, very, very important because we are going to use these terms in SPSS package. So you must know what is nominal scale, what is ordinal scale, what is interval and ratio scale. So these are the 4 scales of measurement: nominal, ordinal, interval and ratio. So nominal is the least scale of measurement is nominal scale because it has only one property, that is only we can label the data. Okay, it is only for labeling the data. Labeling is nothing but we can name the data. Okay, so nominal scale is the lowest scale of measurement. In nominal scale, what we will do means it is also known as categorical scale. For example, gender is a gender. So gender can be divided into how many subgroups? Can I have the answer in the chat box? Gender can be divided into how many subgroups? 2. Okay, actually 3. Male, female, and transgender. Okay, so we have 3 subgroups. Now, so gender is a nominal scale. Thank you. Thank you so much for your answers. Okay, so now gender is a nominal scale because I'm just categorizing the gender into 3 categories. That is male, female and transgender. I'm giving names for this. Only naming alone I'm doing. So labeling for identification. Nothing more I can do with nominal data. So this nominal data satisfy only one property, that is labeling. Okay, so apart from naming, I can also give the label in terms of number. 1 as male, 2 as female, 3 as transgender. So not only in terms of names, we can also give labels in terms of numbers. Even we can give names in terms of letters. M as male, F as female, T as transgender. So the purpose of labeling is for identification. So it is used as labels for identification. The example is gender. So gender, here I have given only 2 subgroups, but actually we have 3 subgroups: male, female and transgender. Okay, can you give some example for nominal scale apart from gender? Come on. Can I have the answers in the chat box? Example for nominal scale. Color, yes. Locality, religion, type of vehicle owned, age. Age is not nominal scale, okay? Age, education will not comes under nominal scale. I'll tell you why. Okay, so if you take a locality, rural, urban, so two subgroup, only we are giving naming, we are categorizing. So it is a nominal scale. Marital status, married, unmarried. So two subgroups. So these are all nominal scale. Okay, so next we are moving to ordinal scale. Type of the management, very good. Type of the management, government, government aided, private. So in this case, we are just categorizing the type of the management into three categories. So it is a nominal scale. Marital status, yes, right. So next one is ordinal scale. So in ordinal scale, you know, it has two properties. Ordinal scale satisfy two properties. We can label as well as we can arrange the subgroups in an order. We can arrange the subgroup in order in case of ordinal scale. So it is higher than nominal scale because it satisfies two properties and hence it is a higher than nominal scale and it is used to arrange the categories in order or sequence. Okay. For example, if you take educational qualification, I'm having that. Yes. Example is educational qualification of parents or students, whatever it may be. So now, you know, 10th, 12th, UG, PG. These are the four subgroups. So now I will arrange the subgroups only in this order. Will I arrange as 12th standard, 10th standard, PG, and then UG? Will I shuffle this order? No, I will not do that. So I will arrange the subgroups only in particular sequence or particular order. So this is called ordinal scale. But if in the case of type of the management, the three subgroups, that is government, government aided, private. In that case, I can shuffle this three subgroups in any order. There is no order for this government, government aided, private. That is why it is nominal scale. Okay, but educational qualification is an ordinal scale because here we are arranging the subgroups in order. Can you give examples for ordinal scale? I have given educational qualification. $12 months in a year, salary. Okay, age. See, age will not comes under ordinal scale. Okay, I'll tell you why. Academic rank of the students, profession. Yes, okay. Sometimes occupation also will start from lower cadre to higher cadre. Okay, order of birth order. First, second, third, fourth. So that is also an ordinal scale. Okay. So ordinal scale satisfy two properties. That is what? It has label as well as order. Okay. And next we are moving into the third scale of measurement. That is interval scale. It satisfies three properties. That is, this is very important, interval scale. So number one, we can categorize the data. We can arrange the data. We can arrange the subgroup in order. In addition to this, it has equal intervals. Okay. In interval scale, it has a reference point or non-fixed zero or equal intervals. So it has, but the fourth property, it will not satisfy the fourth property, that is absolute zero. So what is meant by this absolute zero? For example, you know, if you take the ruler, that is scale, the points between 0 to 1 is equal to 1 to 2. And the points between 2 to 3, 3 to 4, all the points are equal. So that is equal intervals. But there is no fixed zero. What is mean by that fixed zero? Suppose I want to measure the length of my mobile. Okay. I want to measure the length of my mobile. So what I will do, I will take a scale and starting from 0, I will measure the length of my mobile. So suppose it is 10 centimeter length. Let it be 10 centimeter. Okay. Now we start from 0 and it ends at 10. So I'm telling it is 10 centimeter length. Suppose it doesn't mean that I have to start from 0. 0 is just a reference point. Even if I can start from 1. If I start from 1, it will end at 11. But the centimeter is 10 centimeter only. Even I can start from 2 and it will end at 12 and the centimeter is 10 centimeter only. So there is no absolute zero in interval scale. I hope you understand what is meant by absolute zero. There is no fixed zero in interval scale. Just like a reference point, we can take any points in the scale. in the ruler. Okay. Similarly, if you take weight, suppose I'm in a vegetable shop, I want to weigh the potato. So what I will do in the weighing machine, I will put the basket first. Yes. Yes. Okay. So in the weighing machine, I will put the basket. So suppose if the basket is some 50 grams or something like that, means it doesn't mean that we have to make 0. Even with that 50 grams, I can put the potatoes. If the potato is 250 grams, means I will take only 200. I will reduce the 50 grams because the basket weight is 50. So it is not necessary to start with 0. That is my point here. So there is no absolute 0 in interval scale. Only equal intervals. So this interval scale satisfies 3 properties. We can label, we can arrange in order or sequence, as well as it has equal intervals. Okay. So height, weight, temperature, all are examples for interval scale. And next one is ratio scale. So ratio scale is considered as the, am I audible?
Yes, ma'am, you are audible.
Yes, ma'am.
Yes. Okay, thank you. So ratio scale is considered as the highest scales of measurement because it satisfies all the 4 properties. That is label, and then order, and then in equal intervals, absolute 0. The best example for ratio scale is academic achievement of the students. Even I can measure 0 here. Academic achievement 0 means 0 only. So it starts from 0 only. We will start counting the marks. 0, 1, 2, 3, 4, 5. We can't start from 3, 4, 5 or 5, 6, 7 like interval scale. So we will start from 0 only. So it has absolute 0. So it is the highest scale of measurement. It has fixed interval and fixed 0. So the 0 represents the total measure of absence. The absence of something also we can measure in ratio scale. So the example for ratio scale is academic achievement. And one important thing is the interval scale and ratio scale will come under one category in SPSS, because in SPSS, there you will be having only 3 scales of measurement: nominal scale, ordinal scale, and ratio scale. Interval scale and ratio scale together, they'll club and this, it will be given there. So don't search interval scale in SPSS because interval and ratio together will be put up there. Okay. So these are the 4 scales of measurement. One important thing I want to share here, that is the highest scales of measurement can be reduced into lowest scales of measurement. But the lowest scales of measurement cannot be converted into highest scale of measurement. Okay, I'll tell you how. See, for suppose, it happened in some 5 years back or 3 years back. One student, she usually, in order to collect the academic achievement scores, what we will do, we will collect the quarterly test scores or the what else? Half-yearly marks of the students. So we ask the students to collect the half-yearly marks or quarterly marks of the students. But this particular student, what she did means, in like demographic variables, she categorized the academic achievement as, please talking in between. Kindly mute yourself. Okay. So, please talking. Yes. Please, the organizing committee, kindly mute the person who is talking in between. Okay.
Yes, ma'am, I have done that. Thank you. Sorry for that.
No issues. So where we are, yeah. We asked the students to collect the quarterly or half-yearly marks of the student in case of academic achievement. But what she did, in the place of academic achievement, she has categorized like below 35, 35 to 50, 50 to 70, 70 to 80, 80 above. Like that, she categorized and asked the students to put their responses against the categories. Now, she came to me with the data, ma'am, I don't know how to do the analysis. Now, tell me what type of scale she collected, whether it is nominal, ordinal, interval, or ratio. Can anyone give me the answer for this in the chat box? What type of data, what type of scales of measurement it is she collected? It is not ratio. It is not ratio. It is not interval. Okay, that is the problem here. Because once you categorize the data, now she collected ordinal data. Yes, Aparna Mukherjee, you're absolutely LC. Absolutely right. It is ordinal data. So with this ordinal data, we can't do statistical techniques like t-test, f-test, correlation. We can't do that because with nominal data and ordinal data, simply you can do frequency. We can count the data. We can do percentage analysis. We can do chi-square. Only limited statistics we can do with nominal and ordinal data. And we cannot go for higher statistics like inferential statistic like t-test, f-test, correlation. Now, so what I'm telling is, once you collect the higher scale of measurement, the ratio scale can be converted into nominal scale, ordinal scale, interval scale. But the nominal and ordinal scale cannot be converted into interval and ratio scale. So please be very specific while collecting the data. Make sure you are collecting ratio and interval scale in the place of variables. If it is demographic variables like gender, marital status, type of management, locality, in that case, you can go for nominal and ordinal scale. But if it is a continuous variable means, then you have to go for ratio or interval scale. Please don't convert that into nominal or ordinal scale. So this is very, very important point. So the higher scales of measurement can be converted into lower scales of measurement, but the lower scales of measurement cannot be converted into high scales of measurement like interval scale and ratio scale. So with that, the scales of measurement is over. I hope you all understand up to this. If you have any doubts, we can clarify now. Or I will proceed. Shall I proceed? Because we don't have time.
Yes, ma'am.
Yes. Okay. Okay. So next one, these are the basics of statistics. Okay. So this is what we discussed now. So the data can be classified into qualitative data and quantitative data. The other name for qualitative data is categorical data, because qualitative data means gender can be categorized into male, female. So here we have described the data in terms of words, right? So it is categorical data or it is qualitative data. But in terms of quantitative data, suppose if I collect the achieved scores of the students, we can collect only in terms of number. So that is numerical data. So we have two types of data. Qualitative data, it is also known as categorical data because we collect the data in terms of words. Okay, and quantitative data we collect in terms of numerical. So this qualitative data can be further classified into nominal and ordinal. So we discussed enough about nominal and ordinal. So nominal means we have only label. Ordinal means we have both label and order. In quantitative data, it can be classified into continuous data and discrete data. So continuous means it has both fraction and whole number. Discrete means it will be available only in whole number. And this continuous data can be classified into interval scale and ratio scale. It has 3 properties. Ratio has 4 properties. Okay. So I hope you understand up to this. So next one is basic concepts. Some of the basic concepts we are going to discuss. The first one is, yes, population. So population means what? The totality of individuals. Suppose if I'm going to conduct my research among 9 standard students. So all the 9 standard students in Chennai district will be my population. Okay. So the totality of individuals or my population, and sample is nothing but the small subset of the population. So suppose if I have thousands and lakhs of 9 standard students in Chennai district, so it may not be possible to collect data from all the individuals, all the members of the population. So what I will do, I will take a small subset from the population and I will conduct the study. Okay, so the small subset of the population is called sample, and sample size is number of samples selected for the research. It can be 300, it can be 500, it can be 1000. See, even we also commit the same mistake in our department. M.Ed means they have to collect 300 sample. MPhil means they have to collect 500 sample. PhD means they have to collect 1000 sample. So it is mandatory. It is not like that. So it is not based on the level of education we have to fix the sample size. This is wrong. Only the sample will demand the size. Suppose if it is transgender, I can't go for 1000 sample. Even 200 samples more than enough For a PhD thesis, if you're going to conduct the research among transgender, similarly, if you're going to conduct the research among special children, physically challenged or visually challenged, in that case, 100, 200 students are more than enough. So only the sample will demand the sample size and not your degree. Okay, so keep that in mind. Your sample will decide how many samples you have to collect. So usually we'll go for 10% of the population will do. Even we have a calculator to calculate the sample size from the population size. Once you know the population, you can calculate the sample size. So based on the population, you have to fix your sample size, not on the based on the degree. Okay, so sample size is nothing but number of samples selected for the research. And next one is sampling. So sampling is a technique to which we collect the sample from the population. We have probability sampling and non-probability sampling. So probability sampling is for quantitative research, and for qualitative research, we'll go with non-probability sampling technique, convenience sampling, judgmental sampling, so and so. If the case of quantitative research, mostly we'll focus on the probability sampling techniques. Okay, so what technique I'm going to apply in order to select the sample from the population? So that is called sampling, selecting the sample from the population. Next one is parameter. So what is mean by parameter? So collecting data from all the members of the population and calculating mean, median, mode, standard deviation, etc., etc. So this is called parameter. So in other words, we can say parameter is nothing but the population characteristics. So the parameter tells us about the characteristics of the population. So what actually I'm going to do, I will collect the data from all the members of the population, and from the data I will be calculating the measures of central tendency, dispersion, so and so, and this will tell us about the characteristics of the population. So parameter means population characteristics. Okay, so what is it? So if I'm going to collect the data from all the members of the population, it is called what? I want the answers in the chat box. Collecting
Census.
Yes, census. Okay, so census means collecting the data from all the individuals, all the members of the population. So what does mean by statistics? Statistics means it will describe about the characteristics of the sample. So statistics, it is okay. So from the population, we will select the sample. So among this sample, we will be collecting the data. After collecting the data, we will calculate mean, median, mode, etc., etc. So these mean, median, mode, standard deviation will describe the characteristics of the sample. So this is called statistics. So parameter will describe the characteristics of the population. Statistics will describe the characteristics of the sample. Now tell me, collecting the data from the sample is called what? Collecting data from the sample is called? No, it is not statistics. Any other answer?
Survey.
Sampling. Yes, it is called survey. Okay. So collecting data from the sample is called what? Survey. So if you're going to collect data from all the members of the population, that is census. If you're going to collect the data from the sample, that is called what? Survey, because it was asked in NET examination, that census question. So long back, I read in the NET question papers. Okay. So next we are moving into the classification of statistics. See, now the statistics can be classified into parametric statistics and non-parametric statistics. Okay, so now we should know when to apply parametric and when to go with non-parametric statistics. So this is very important. So the statistics can be classified into parametric statistics and non-parametric statistics. So parametric statistics means it will be the data we will be collected in the form, it will be in the form of interval and ratio scale. In case of non-parametric, it will be in the form of nominal and ordinal. Okay, and you just forgot about interval, ratio, and nominal ordinal. The major difference between parametric and non-parametric test is if the distribution is normal, then we have to go with parametric test. If the distribution is not normal, then we have to go with non-parametric test. That is, even though I have collected 1,000 samples, the distribution is not normal, then you have to go with non-parametric statistics. Even though I collected only 50 samples, but still the distribution is normal, then I can go with parametric statistics. Okay, so the major difference is if the distribution is normal, then we can go with parametric statistics. If the distribution is not normal, that is distribution free, then we have to choose non-parametric statistics. And one more thing is, if the sample size is large, we'll go with parametric test. If the sample size is small, we'll go with non-parametric size. But only one rule: if it satisfies the normal distribution, then go to parametric test. If it is not normally distributed, go to non-parametric test. So what is meant by normal distribution? Yes, I'll explain that. What is mean by normality? I'll give you one example. Suppose in a class of 50 students, okay, in a class of 50 students, I'm going to check the height of the students. If I check the height of the students, among 50 students, 10 students will be very short, and 10 students will be very tall, and 30 students will be around the average height. Okay, so this is a normal distribution. Similarly, if you take the weight of the students, 10 students will be underweight, 10 will be overweight, and some 30 will be around the average category. So this is a normal distribution. So at the extremes, we will have low number of students. In the average, more number of students will fall under the average, moderate category. So this is called normal distribution. Similarly, if you take the intelligence of the students, in the class of 50 students, 10 students will fall under slow learner, and 10 students will be highly gifted, and the 30 students will be falling under average category. This is called normal distribution. So whatever the traits, whatever the characteristics you take, you will get like this only. At the extreme ends, you will be getting less number of sample, and at the middle, at the average, you will be getting more number of people. So this is called a normal distribution. So the normal distribution will be like a bell-shaped curve. So if you draw a graph for a normal distribution, you will get a bell-shaped curve like this. Okay, bell-shaped. So less number of plots at the extremes, and more number of plots at the moderate value. So that is normal distribution. If the distribution is not normal, if it is skewed, if it is positively skewed or negatively skewed, if it is kurtosis means platykurtic, leptokurtic, mesokurtic. Mesokurtic means it's normal only. If it is leptokurtic or platykurtic, in that case, it is not normally distributed. Then you have to go with non-parametric test. So mostly the students will ask, ma'am, I have collected 1,000 samples, but still my distribution is not normal. Then what I have to do? You have to choose non-parametric test, no other go. So unless and otherwise your distribution is not normal, you should not choose parametric test. You have to go with non-parametric test. Okay. Now next one is we have inferential. See, we have differential statistics and inferential statistics. I will be explaining that in the next slide. Okay. Okay, I hope now you understand what is meant by normal probability. So while starting your analysis part, first you have to check the normality. Only if it is not, the normality is good, then you have to do with parametric statistic, that t-test, f-test, correlation, regression, so and so. If it is not normal, then you have to choose the equivalent statistic techniques. Say, I'll tell you that. Okay, so in parametric test, we will we'll do t-test. So t-test means what? For what purpose we are doing t-test? If the demographic variable is classified into two subgroups, for example, marital status, married, unmarried. So now the subgroup is divided into two. So for this, we will be doing t-test. So if the demographic variable is classified into two subgroups, in that case, we will be doing t-test. And what is the equivalent test? T-test for non-parametric. So if the distribution is not normal, instead of t-test, you have to do Mann-Whitney U-test. Okay, you should not go with t-test if the distribution is not normal. If it is not normal, then you have to choose Mann-Whitney U-test. Okay, similarly, next one is F-test. So F-test means what? Suppose if the subgroup is divided into more than two. Suppose type of the management, government aided, private. So now we have three subgroups. So if we have more than two subgroups, in that case, we will be doing F-test. Okay. So what is the equivalent F-test under non-parametric test? That is Kruskal-Wallis test. So that is the equivalent F-test under non-parametric test. And next one is correlation. Somebody is talking in between. Kindly mute yourself. Okay. So under correlation, if it is a parametric test, we will be doing Pearson correlation. Okay. Pearson correlation if it is a parametric. If it is non-parametric, then we will be doing Spearman rank correlation. It is Spearman rank correlation. I hope you understand. So first you have to check after entering the data, first and foremost, you have to check the normality of your data. Okay. If the distribution is normal, then go with parametric statistic like t-test, F-test, Pearson correlation. If it is not normal, then go with non-parametric statistic like Mann-Whitney U-test, Kruskal-Wallis test, and Spearman rank correlation. I hope it is clear up to this, right? Shall I proceed further? Any doubts or clarification? Okay. So I'll move on to the next one. Okay. So the next one is, again, statistics. So again, the statistics can be classified into descriptive statistics and inferential statistics. So what is differential statistics? Measures of central tendency and measures of dispersion. So under measures of central tendency, we have mean, median, and mode. And under measures of dispersion, we have range, quartile deviation, standard deviation, average deviation, so and so. So these techniques comes under descriptive statistics. So this, after calculating measures of central tendency and measures of dispersion, we can describe the data that the median, the average value is this, the dispersion value is this. So we can describe the population from the output of this descriptive statistics, right? So it will describe the population under study with the help of mean, median, mode, range, standard deviation, quartile deviation. And inferential statistics means that comes a t-test, F-test, correlation, regression. So these statistical analysis comes under inferential statistics. So with this inferential statistics, we can make prediction. Prediction is regression. And also we can draw conclusions about the sample. Okay, we can see two things we can do. Three things. Number one, we can compare the subgroups. Comparison of subgroup is t-test and F-test. We can compare male, female, okay, between two subgroups. That is male, female. Among the subgroup. Among means more than two. Government aided, private. So more than two subgroup means we will be comparing among the three subgroups. So either we will compare or we will find the relationship. That is the correlation. We will try to find the correlation between learning styles and academic achievement of the student. So that is what correlation, or we can say the relationship. Yes, for large sample only, we have to calculate t-test and F-test. So more than large sample, we have to check the normality. Even though the sample size you have collected may be large, but if you don't get a normal probability curve, if the distribution is not normal, in that case, you have to go with non-parametric test only. Okay, see why we in PhD, we are collecting more number of sample, once you increase the sample size, the error will decrease. Okay, if you collect data from 50 sample, in that case, the error will be more. Once you increase the sample size to 100, 200, 300, 400, 500, so both are inversely proportional. So if the sample size increases, you can minimize the error. For that purpose only in PhD, we were asked to collect more number of sample. Okay, but M.Ed level, it is initial stage. So the students should understand what is research and other aspects. So here we won't concentrate much on the size of the sample, but PhD, we have to minimize the error. That is the reason you were asked to collect more number of sample, large sample in case of PhD. Okay. But though you have collected large sample, sometimes you may not get normal probability. What is the reason for that? Can I get the answer in the chat box? I have collected 1,000 sample, but still the distribution is not normal. What is the reason for that? Platycertic, this discrete sample, bias in sampling, very good. Bias in sampling, then improper sampling, okay. See, usually what the students will do, they will go to the school, they will give the tools, the questionnaire, they will distribute the questionnaire, and next day they will come and collect the data. If you do so, definitely you will not get normal probability. What you have to do? You have to get the permission from the heads, from the principal, from the headmaster, or from the principal. Get proper permission, and you have to sit with the students. You have to explain for what purpose you are doing the research. You try to create rapport with your sample and read the question one by one. Explain the question one by one, and then ask them to give their responses. Suppose the students may not know what to strongly agree, undecided, disagree, strongly disagree. They may not know where to tick, right? Sometimes they will tick in all the columns, or they will tick all strong agree, or same response in all the columns they will give. So in that case, you will not get the normal distribution. So if the samples fails to respond properly, you will not get normal distribution. I hope I clear. So what you have to do, data collection is very, very important. The students will concentrate more on tool construction and other thing, but they will not concentrate much on data collection. But data collection is very, very, very important. Yes. Okay, I'll do that in the next class. Okay. So data collection is equally important like tool construction. Though your tool may be very good, okay, you may be having high value of reliability and validity, but you fail to collect the data properly in person, then you will not get normal probability. So data collection is very, very important, very, very crucial in the research process. Okay. So that's all. So statistics can be classified into descriptive and inferential statistics. Under descriptive statistics, we have measures of central tendency and measures of dispersion. So with this only we can describe the characteristics of the population. But under inferential statistics, we have t-test, f-test, correlation, regression. With that, we can compare the subgroup, we can compare between groups, we can compare among the groups, and we can find out the correlation between two variables. Okay, we will be doing comparison between two subgroups. Subgroup means male, female, English medium, Tamil medium, rural, urban. So we will be comparing between two subgroups or more than two subgroups. But in case of correlation, we will be correlating two variables: learning styles, academic achievement; job satisfaction, mental health; brain dominance, academic achievement. So this is variables. We have to correlate the variables under correlation. Okay. In one case, I have read in one thesis, they have find out the correlation between, for example, academic achievement and gender. Okay, it is totally wrong. You're not supposed to do like that. So we can correlate only two variables. Okay, so you have to be very, very specific in. And also we can predict the data. So these are inferential statistics. So statistics part is over. And next one is types of hypothesis. See, usually the students will get confused between types of hypothesis and forms of hypothesis. So types of hypothesis, I will brief more in the next class, in the next session. Okay, now I'll give the types of hypothesis. We have three types of hypothesis, that is research hypothesis, statistical hypothesis, and operational hypothesis. And usually we will stick with statistical hypothesis. I'll give one example for statistical hypothesis. There is no significant difference between the between the mean score of male and female in their academic achievement. So here we are mentioning as mean score, right? Because while comparing, we will compare the mean scores of the subgroup. So this is called the statistical hypothesis. So this statistical hypothesis is subjected to statistical analysis. So we have three types of hypothesis: research hypothesis, statistical hypothesis, and operational hypothesis. And forms of hypothesis, we have two forms of hypothesis. That is, can anyone give the answer in the chat box? What are the two forms of hypothesis?
Is it directional and non-directional?
Yes. Yes, correct. What is the other name? Yes, null is correct. Yes, null and alternate. Very good. Yes, yes. Thank you. Okay. So the two forms of hypothesis are null hypothesis and alternate hypothesis. In case of null form of hypothesis, we have to nullify the statement. Nullifying the statement means there is no significant difference between the mean scores of male and female in their academic achievement. So that is what null form of hypothesis. So this is called non-directional hypothesis because I'm not giving any direction. There is no significant difference. I nullified the statement. So this is called non-directional. So null form of hypothesis, or we can call it as non-directional hypothesis. It is denoted by letter H naught. If it is alternate hypothesis, we will be giving directions. Direction in the sense there is significant difference between the mean scores of boys and girls in their academic achievement. So I'm giving direction. There is significant difference. So this is directional hypothesis, and it is denoted by the letter H1 or HA. In some book it was given H1. In some statistics book it was given as HA. Both are correct. Okay. Okay. So null form or non-directional form, alternate form or directional form. Okay. Now, next question is when we have to go with directional form of hypothesis and when we have to, because in one PhD Viva, the investigator, she has given formulated directional hypothesis. There is significant, there is significant, there is significant, all directional hypothesis. Then I asked her, why did you formulate directional hypothesis? She said, ma'am, I know definitely there will be significant difference between boys and girls in terms of academic achievement, in terms of this and that. So I framed a directional hypothesis. Do you think this answer is correct? Yes? Is it correct or not? No. Yes. So we can't formulate directional hypothesis unless and otherwise you have a proof. That base, that is very, very important. So what proof? Suppose I referred because it will contain researchers' bias. Yes. So in what case we have to go with directional form of hypothesis means as a researcher, I reviewed 100 studies. Out of 100 studies, in 80 studies, I found that there is significant difference between boys and girls in terms of academic achievement. So now I have proper evidence and proof that there is significant difference between boys and girls in terms of hypothesis. In that case, I can go for directional hypothesis. So I can I can defend myself during the time of Viva. I reviewed these many studies and out of 180 studies shows that there is significant difference between boys and girls. So I stick on with directional form of hypothesis. Okay, so unless and otherwise you have proper evidence, don't formulate directional hypothesis. We have to formulate non-directional or null form of hypothesis. Okay, so the next, so null form of hypothesis means we will be getting two-tiled, and if it is directional form, we will be getting only one-tiled test. Okay, so next, last topic, with that I will wind up. So level of significance. So this is another one important concept, the level of significance, because in our PhD thesis, we will be fixing the level as 5% level of significance or 1% level of significance. So what is meant by level of significance, this 5% level and 1% level of significance? That is, level of significance means, we ourselves as a researcher, I will admit that in my research, there will be some 5% error or 1% error. Okay, so as researchers, we ourselves, we will commit that my research will contain 5% of error or 1% of error. So that is called level of significance. Usually in social science, in humanities, we will be fixing this kind of level of significance while doing the data analysis. Why? But in science, they won't be doing this kind of level of significance. They won't do this. You know why? Because suppose they are going to launch the rocket. Okay, while launching the rocket, if I know that it has not 1% of error, will I launch the rocket? We won't launch because we have invest more money on this project. So we make sure it is 100% error free or 0% error. Only then we will launch the rocket, because there we are doing research with the tools and apparatus. It is machines. But in social science, we are doing research among human beings. So human beings will never ever reveal the truth. Right? So we admit ourselves that there will be a 5% error or 1% error. So only in social science, we will be fixing these kind of level of significance as 5% or 1% level of significance. The actual meaning is, see, yes. So what is mean by level of significance? The fine line which discriminates between the occurrence of an event by chance or not by chance. That is, suppose, so definitely there will be a significant difference between boys and girls in terms of academic achievement. Definitely there will be significant difference, not only in terms of academic achievement, in terms of rural, urban, in terms of English medium, Tamil medium, but whether the difference is significant or not, that is the point here. Okay, so that is very, very important, whether this difference is significant or not. So the fine line which discriminates between the occurrence of an event by chance or not by chance, that is called level of significance, and it is also known as confidence level. So level of significance, it is also known as confidence level. Okay, I'll give you one more example. So what is this 5% level of significance mean? Suppose, so with that I'll conclude. Okay, suppose I repeat my experiment 100 times. If I'm going to repeat my experiment 100 times, 95 times I will arrive at the same findings, and there is a chance of arriving at different findings 5 times. So the chance of error is 5% here. So the confidence level is 95%. I hope you understand. So the confidence level is 95% and the error is 5%. Similarly, if I repeat the experiment 100 times, 99 times I will arrive at the same finding, and there is a chance of 1% error. So that is, the error is 1% and the confidence level is 99%. So in social science, we take either 5% or 1% level of significance. The 5% can be written as 0.05 level of significance, and the 1% level of significance can be written as 0.01 level of significance, or it is also known as the confidence level, that is 95%, which can be written as 0.5 level of confidence level, or 99% or 0.99 confidence level. So this is known as level of significance. So in those days, when I was doing my M.Ed, we used to fix 5%. Even at the back of every statistics book, we will be having this level of significance separately for t-test, for f-test, for correlation, or for all the statistical techniques. We will be having this level of significance, not only for 5%, 1%, 5%, 10%, 15%, 20, 25, up to 50% also we have table value, but mostly we stick on with 5% level of significance. Okay, so that's all about level of significance. So these are the basic concepts which first we need to understand before moving into SPSS. I hope I clarified the basic concepts and fundamentals. If you have any doubts, we'll clarify now.
Dear participants, if there are any questions, please put it in the chat box.
People are
I think
waiting
there
for
is
the
no
feedback form, it seems.
Yes, ma'am. I think there is no doubt in your session, it seems, ma'am. It was a crystal clear presentation. Thank you. Thank you, ma'am. You gave a clear idea on the fundamental of research. This will be very much useful for young budding researchers. Thank you for your wonderful session, ma'am. I think we had one more,
Ma'am?
one question. Yes, sir. Yes, sir. You're
Ma'am, I
audible.
have a question.
Yes, yes.
Good evening, ma'am.
Good evening, Kishore.
The session was good, ma'am. I have one doubt. Ma'am, whether the sample size will indirectly or directly influence the level of significance?
Yes, of course. See, as I told already, if the sample size is less, the error will be more. So at 5% level of significance, you will not get significant difference. So you have to increase the error to 10% or 15%. Only then you will get significant difference. Can you able to understand? So if the sample size is less, you have to fix the error to a greater extent. That is why we have to increase the sample size in order to minimize the, suppose instead of 1000, I go for samples 2000. In that case, even I can fix the error to 1%. I hope I clarified your doubt.
Yes, ma'am. Thank you, ma'am.
Okay, checking normality, I will be handling in the next class. That is tomorrow. Okay.
Good evening, ma'am.
Yes.
Ma'am, I have a doubt. Actually, you
Yes.
told about T-test and F-test. I want to know about Z-test, ma'am. Where will we use Z-test, ma'am?
Yes. See, about that is T-test. We have many types of T-test, F-test. All those things I will be discussing in the next class. F-test, ANCOVA, ANOVA, all those things discussing in the next class. So I don't want to confuse taking T-test and the types of T-test in today's presentation. I will be handling in the next class, Shahida.
Yes, ma'am. Thank you so much, ma'am. And it was a very useful presentation also. And you gave very simple examples, which was very easy to understand. Thank you so much.
Thank you, Shahida. Thank you. Thank you so much for your feedback. Okay, Ambika.
Thank you. Thank you,
Good
audience.
afternoon, ma'am. First of all, congratulations. It was a very nice presentation and I got my points clear. One small doubt is that, is it standard, like for social research, we have to use 95% confidence level, or it is according to the researcher's willingness that if I want, can I do 99% significance level?
Why not? Why not? See, so in tomorrow's SPSS class, I will tell you, if the p-value is less than 0.01, in that case, you can fix the error to 1%. Nothing wrong in that. Okay, not all the times we will fixing 5%. You can go for 1% also. Nothing wrong in that.
Okay, ma'am. Thank you. Thank you so much.
Okay, you're welcome.
I think you have cleared all the doubts, ma'am. Thank you for your answer for all the questions. Now I request Mrs. Sheila to propose a vote of thanks.
Good afternoon to one and all present here. A moment of gratitude makes a difference in the attitude. On behalf of Faculty of Education, Dr. MGR Educational Research Institute, we are grateful to make a gratitudinal note. Thank you so much, ma'am, for sparing your valuable time to share your insight on SPSS. You have shared about you have given a brief idea of research steps, variables, the scales of measurements, basics of statistics and the basic concepts, statistics, types of hypothesis, and the level of significance. Thank you so much, ma'am. We would like to extend our gratitude to our Honorable President and all the executives for granting us permission to organize this workshop. We render our heartfelt thanks to Dr. K. Geeta, Principal, for our motivation and initiative towards this workshop. And our note of gratitude to all the principals, professors, research scholars, and students from various schools and our beloved students. It's a great honor for being with us today, and thank you once again. Please join with us tomorrow at 2 p.m. for second day workshop. Thank you, ma'am.
Thank you. Thank you all.
Thank you, ma'am. Thank you so much for a wonderful session, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Dear participants, there is no feedback today. Kindly join us tomorrow at 2 p.m. Thank you.
Thank you so much, ma'am.